Swayam Prabha. Digital India. Educated India.
Welcome to Module D, Lecture 11. In this lecture, we shall discuss about analysis of multi-lane highways as per Indo Highway Capacity Manual 2017. In lecture 10, I introduced to you to Indo HCM, what was the context for development of Indo HCM, and mainly discussed about the capacity and LOS estimation of undivided inter-urban roads, namely single lane, intermediate lane and two lane roads. All these are undivided roads. Then various key concepts, for example, the concept of stream equivalency factor, which is newly introduced in Indo HCM, then base conditions, how we estimate the capacity under base condition, relating it to operating speed for cars, standard cars. Then whatever base capacity we estimate, how various adjustment factors are applied on that to account for the capacity under prevailing conditions, and then how we are estimating the LOS for undivided interurban facilities, and then took some example problems to explain you how for undivided road segments we can calculate the level of service. Now, with this background, today we shall discuss about multi-lane highways, how the multi-lane highway segments can be analyzed as per again Indo HCM 2017. In Indo HCM, multi-lane highway segments for divided interurban highways operating under mixed traffic conditions prevailing in Indian condition. This is analyzed, or these multi-lane segments are analyzed considering uninterrupted flow facilities, considering them as uninterrupted flow facilities. That means, these are the segments where there is no fixed causes of delay or interruption external to traffic stream. That is as per the definition of uninterrupted flow facilities. Considering a realistic situation which can be considered as uninterrupted flow segments, there are certain aspects which are highlighted. For example, median openings spaced at least 1 kilometer apart, because often there are median openings which are placed on multi-lane highways, which are not really expressway category, but these are general multi-lane highways. So, there are median openings, and what we are saying that if we are analyzing a segment as uninterrupted flow segment, then median openings at least should be 1 kilometer apart. Similarly, there should not be any major access roads connecting to the highway in those segments. There could be minor roads which are joining such highway segments, but in all those minor roads, the traffic volume is substantially low throughout the day. So, that means the volume of traffic is so negligible, which is entering or exiting highway. Practically, the operation on the facility is not interrupted to that extent by external factors. So, we can eventually consider it as uninterrupted flow facility. So, with this, now One more or two more things which are very important before I proceed further. One is that the capacity and LOS for 4-lane and 6-lane divided interurban highways, which are included in the manual in the HCM, all those roads are considered to be in plain and rolling terrain, because such kind of 4-lane, 6-lane road in mountainous and steep terrain is very rare. So, the analysis, capacity and LOS analysis which is presented, it is presented for 4-lane and 6-lane divided interurban roads only in plain and rolling terrain, not in mountainous or steep terrains. Second, the capacity values and LOS estimated for multi-lane divided highways as per the methodology what we are going to discuss are not applicable for the expressways in India. Interurban expressways are also there, at least those categories of road are considered as a category, a separate category. And why the capacity values and LOS criteria are not applicable? Because although both are divided facilities, expressways are also divided facilities, but the major difference is in the nature of traffic and access control. The kind of access control what we consider in multi-lane highways, there are multiple connections. Maybe the minor connections are there, traffic volume is not significant. So, we consider them to be like in an uninterrupted facility, but the level of access control on multi-lane highways and level of access control on expressway, interurban expressway is not comparable, because in interurban expressways are completely access controlled facilities. The second thing, the nature of traffic is also very different. Highway, multi-lane highway also cater to long distance traffic. So, mobility is very important, but often because of too many connections, presence of junctions at grade junctions and so, and also the land use, the kind of there is no fencing or barricading normally along these highways, dense development, roadside development in Indian condition. So, you will also find for some segments there may be completely local traffic is segregated, but for some segments maybe part of the local traffic is also using the highway, getting mixed up with the long distance traffic. So, the type of vehicles are quite wide, in a quite wide range, little slow moving to fast moving, everything in there, size to nature of the acceleration, deceleration, speed capability, everything is different. So, the nature of traffic and also the nature of access control, both things are not comparable in these two types of facilities, that is interurban multi-lane highways and interurban expressway. So, the methodology what we are going to discuss now, that methodology for capacity estimation and LOS or the values also, right, particularly the values methodology, many cases the steps, some steps might be similar, many of the steps also could be similar, but the values what we are going to say, these are applicable only for multi-lane highways, which segments which can be considered to operate under or considered operating under uninterrupted flow facilities as uninterrupted flow facilities, and these are not applicable for expressways in India. That we must understand clearly. Like the undivided roads, here also the base conditions are defined. For example, like what are the base conditions again? Nearly idealized situation. For example, the road is passing through plain and level terrain, no horizontal curve, no vertical gradient, traffic lanes exactly 3.5 meter wide, not less than that, pavement shoulders of minimum, paved shoulders of minimum 1.5 meter followed by unpaved shoulder, minimum median width is 2.5 meter, IRI roughness indicating the surface condition, IRI less than 2.7 meter per kilometer, no direct access point, no side friction, no accident at the time of investigations. So, all these describe the base condition or nearly idealized scenario. And as usual, we first focus on base condition and then try to apply necessary corrections to reflect the prevailing condition or to represent the prevailing condition. So, the methodology for multi-lane highways which has been prescribed or described in the manual, this can be used for analysis of existing facility and also for new facility. When we are applying the analysis for existing facility, the focus is primarily on determination of performance of an existing segment under existing or the projected traffic demand in the future. How the segment is operating now or the existing segment is expected to operate under projected traffic demand. And since the road is existing already, the effect of several other design features, on capacity and LOS can be assessed. That provides an opportunity, right. This provides an opportunity to actually assess the effect of several design features on capacity and LOS. On the other hand, when we are applying the methodology on new facility, the basic purpose is planning and design of a new facility for a given or estimated ADT, average daily traffic. This is a new facility we want to develop, which we know what is going to be the ADT, that what ADT it has to handle, and therefore, we want to assess and basically try to see how many lanes we required and such kind of questions we try to answer. So, the details of geometry and various other inputs we cannot go and measure from the field. It is not possible, the data available is limited, and most such data we can either assume that okay, we want it to be like this, or we can take as recommended default values that okay, whatever is the standard we try to provide that. So, many things are actually assumption. Once we have decided the what kind of whether we want to apply this methodology for existing facility or a new facility, then the next step, general steps I am telling is the estimation of stream speed. And here what we mean by stream speed, because it is actually SMS, space mean speed. So, I have written here as SMS, and why we need that, because generally for what was done actually how it was developed, because the data was collected at different traffic volume level and also the corresponding speed, because the speed flow relationship was actually developed. Now, once the speed flow relationship is developed, we may simply use that later, but when if you are trying to develop it, obviously you need the speed SMS at different volume levels. Even otherwise also, if you want to analyze an existing road for a peak hour, you need the what is the speed and what is the flow. You need to calculate or measure the SMS, that is also required. And in this all these cases, these are uninterrupted facilities. So, flow equal to density into speed, and that speed is space mean speed. So, that relationship is assumed. Many cases it is also assumed that they follow this Green-Schultz model in terms of speed flow, flow density and speed density relationships. Then the next step is estimation of operating speed, because you know the base capacity, as I have mentioned in earlier case also undivided roads, for this divided multi-lane highway segments also the base capacity is related with the operating speed, which is 85th percentile speed of standard cars, that is small cars, under low flow condition. And as I have mentioned earlier, I want to repeat it again, that low volume condition means we are saying the time headway 8 seconds or more. So, that in a way represents the low flow condition. So, we need to calculate the 85th percentile speed of standard cars, and that we can take as operating speed. Then the next step is estimation of passenger car unit, because whether you want to develop speed flow curve or whether you want to assess the LOS for a given volume level, you have measured traffic in terms of the number of vehicles under different categories. So, we need to convert them into equivalent homogeneous streams using in terms of want to express it in terms of PCU. So, there are two ways, as we have again discussed earlier. One is use dynamic PCU values. So, many such similar segments, multi-lane, 4-lane, 6-lane divided roads were taken in different parts of the country, lot of data were collected. So, composition was also changing. So, for a given or observed range of compositions, you take a vehicle type, it says what is the minimum share to what is the maximum share that is observed in the whole database, right, in different parts. And then accordingly what are the PCU values. So, dynamic PCU values are given, say for a particular vehicle type, say for bus, okay, or bigger cars, the PCU value is from x 1 to y 1 or x 1 to x 2 for the composition of that particular volume, traffic type, vehicle type varying from y 1 to y 2. So, for a observed composition range, what is the PCU range that is given. So, one can use the dynamic PCU value or directly use stream equivalency factor. As I said last class, I discussed lecture 10, I discussed about this concept of stream equivalency factor. So, you can directly use the stream equivalency factor to convert vehicles in terms of number to directly in terms of PCU. So, again for 4-lane divided, 6-lane divided roads. So, how the stream equivalency factor can be modeled, those are also given. So, you have a choice either to use dynamic PCU values or directly use the stream equivalency factor, use the equation, calculate the stream equivalency factor for a given situation and use it. Then the next step is estimation of traffic flow. Now, you have the collected classified traffic volume data and also the stream equivalency factor or dynamic PCU value. So, you are able to now express the traffic flow in terms of PCU per hour. Then the next step is with the VOS and the type of road and everything, you estimate the base capacity. So, the equations are also given, you use the base capacity equation, appropriate equation you use and calculate the base capacity. Then estimation of adjusted capacity. Adjusted capacity means under prevailing condition. So, we have to apply multiple factors to convert base capacity to adjusted capacity for conditions such as horizontal curve, gradient, road roughness, shoulder type and width and median width, etc. See, normally the carriageway width is not taken because or lane width is not taken because lane widths are for multi-lane facility not really non-standard. Everywhere you will find multi-lane roads 3.5 meter per lane, there is not much variation. So, that is not included here. So, then the next step is actually estimation of level of surface. So, what we need to do that? Here in this case the measure which is used is actually density, but like as I discussed in 2-lane road undivided road case, right, undivided segments, particularly 2-lane two-way movement and intermediate lane also, that here the although for multi-lane highways the measure is actually density, but the corresponding V/C thresholds are also given. It is again based on the data. Based on the data and some further analysis, you are assuming this relationship in the background that flow equal to speed into density, assuming Greenfield's relationship also you have so much data. So, you could also carry out cluster analysis to see what are the corresponding threshold value. So, as the density thresholds are also given, along with that volume to capacity thresholds are also mentioned, right. So, table will have the LOS A, B, C, D, E and so, and then you know what are the density thresholds, what are the corresponding V by C threshold. V by C, as I say, is always very helpful for the practitioners, but remember that the underlying basic measure that is considered for defining the level of service is the density, but you can also get the corresponding V by C thresholds, because it is very easy for the practitioners if you are directly getting a V by C threshold value. And for that also, of course, we need to measure or estimate volume and SMS, because once the volume and SMS only you can measure, right. You cannot measure directly the density. So, density is measured indirectly from volume and specimen speed, and once you have done that, you have calculated the density, calculate volume to capacity ratio, then you compute the traffic density as I said, and you just compare it with the threshold density values and may also check using the V by C ratio. So, one value you can take it as for getting the LOS and another you can use for checking it. So, now let us go back. So, what are the key aspects? The extreme equivalency factor, you already know what is extreme equivalency factor. Now, these 4 lane divided highway segments and 6 lane divided highway segment, these are the models which are or equations which are given for calculating the extreme equivalency factor for 4 lane and 6 lane divided highways respectively, as I have shown in equation 4.47 and 4.48. So, the proportion of different vehicle types and total number of vehicles and how they are getting related to explain the AC, that is given. So, directly if I know what is the total volume in number of vehicles and if I know the proportion of different volume in the total volume, then I can simply use those proportion number of total vehicle in these equations as appropriate, whether it is 4 lane or 6 lane divided highway, I can directly get the stream equivalency factor. Then the base capacity estimation, like in previous case and also as I explained just now, the base capacity for 4 lane and 6 lane divided highway segment is expressed in terms of the operating speed. So, once you know the operating speed for 4 lane divided highway, use equation 4.49 or 6 lane highway, use equation 4.50. This equation are for my module D. So, it is 4 point and then I am continuously using the number. If you actually go to Indo HCM, the number may be equation number may be different, and obviously it will be different, not maybe, but it will be different. So, you can use these equations. Once you know the operating speed, you can calculate the base capacity. Now, so that you get a feel, I have also reproduced the value from table 3.6 Indo HCM 2070 for Indo HCM 2017 for various operating speed like 70 kilometer per hour, 80 kilometer per hour, 90 kilometer per hour, 100 kilometer per hour. Then what is the base capacity for 4 lane highway and 6 lane highway, and these values are actually capacity PCU per hour per direction. Okay. So, if we are considering 4 lane highway, that means the total capacity in one direction, which includes 2 traffic lane, is given here. Similarly, 6 lane in one direction mean this is the total capacity in PCU in one direction, which includes 3 lanes. So, you can see how the get a feel about the capacity values, and in between, suppose I want to get something between 70 and 80 for 4 lane highway, I can interpolate the values and get it, or if it is 4 lane, I can directly use this equation 4.49 to calculate my values. Both options are there. Then, as I said, we need to apply lot of adjustment factor. What is observed from the data, the gradient curvature and roughness these have got direct impact on the operating speed, and operating speed also influence the capacity. So, the corrections are actually applied on operating speed, so that you use that adjusted operating speed in the previous equation as I have said, and you get the actual capacity. So, these corrections are, as I said, two different equations are given as shown here, one for 4-lane divided highway, another for 6-lane divided highway, and the corrections with respect to IRI, International Roughness Index, with respect to gradient and with respect to curvature. Now, curvature is expressed in degree per kilometer, gradient in percentage, and IRI, no adjustment is required for IRI if it is less than 2.7 meter per kilometer. Okay. Otherwise, you need adjustment. So, in case of new highway facility, if it is an existing, the operating speed, you can go and measure and then actually say what is the operating speed. If it is a new facility, then operating speed for base condition can be assumed as the operating speed as you are obtaining or as you observe in similar highway facility. Now, coming to the capacity adjustment also need to be done not for the directly for the gradient, curvature and roughness. Here you adjust actually the operating speed, and then operating speed is going as input for base capacity estimation. So, that way the effect is taken. Separately, directly on capacity, the influence is PSW and UPSW. PSW is basically the shoulder width, paved shoulder width PSW, and the UPSW is the unpaved shoulder width. And these are for 4-lane highways, different equations are given for different median width. If the median width is greater than 2.5 meter, then you use equation 4.53. If it is less than 2.5 meter, you use 4.54, and one equation is given on 6-lane divided highway, where you are making 6-lane. Normally, there is no such issue with the median, largely there is no such issue with the median. Now, as I said that in all these equations, C is the base capacity, then PSW is the difference between actual and the base width for pavement shoulder. For example, base width for pavement shoulder, what we assume 1.5 meter paved shoulder. So, what is the actual paved shoulder width in meter minus 1.5, that in meter will go as input for all these equations 4.53, 54 and 55, and UPSW is the width of the unpaved shoulder in meter. Now, once you have done that, all what you need to know little bit, what I have not mentioned is the LOS threshold, that is I am showing here. LOS A, B, C, D, E, V by C is always very important, because V by C greater than 1 means it is LOS safe. Okay. So, that way straightway you can say that it is LOS safe. So, here the density PCU per kilometer per direction, these thresholds values are given for A, B, C, D, E and also for F, and the corresponding V by C ratio, as I said that for practitioners you will always, for nearly all different types of segments which are analyzed and included in Indo highway capacity manual, they try to give the corresponding V by C ratio values, because it is the professionals, it is very easy, because finally whatever maybe you take the density, but how the density gets related. So, because the flow is something, traffic volume measurements and converting to PCU, that is something which is very easy. So, if there is a corresponding V by C thresholds are also there, it is very easy. So, here the limiting service volumes are also given, right, and the recommended design service volume is mentioned here. I have reproduced, this is taken as LOSB. So, that is the threshold which is taken for further improvement or upgradation of the road, and it is expressed normally as per Indian convention expressed per day, but as you know the capacity is normally expressed in PCU per hour, but there is a relation between the ADT and the the peak hour traffic or the design hourly volume, and all these relations are inbuilt, right. So, this is again expressed so that you calculate the ADT or ADT and then directly you can compare, right. So, what is my daily traffic volume and what is the DSB that is recommended, and then accordingly you can decide what upgradation is necessary if it is required. So, similarly, this is the table for 6 lane divided highways, only the threshold values are different, but nothing much to explain. Now, coming to an application part, let us take an example first. Determine capacity and level of service of a 4 lane divided highway in plain terrain, obviously all are in plain terrain, with the following characteristics. Operating speed under base condition is given, lane width standard 3.5 kilometer, gradient is given, total volume is given in vehicle per hour per direction, SMS is given, space mean speed it will be required. For this volume we want to calculate always. So, what is the SMS that will be required? Paved shoulder width is given, median width is given, curvature is given, IRI is given, and traffic composition, traffics are in actual number, these are given. But when you know the actual number and you know the total number of vehicles 1250 vehicles per hour per direction. So, you can actually calculate the proportions which are required as input for the equation. So, the stream equivalency can be calculated. Remember that these are all proportions. Here numbers are given, but total and numbers are given. So, you can calculate the proportions and then accordingly you can fit the values to get the stream equivalency factor as 1.63. Once you have got the stream equivalency factor, your value is 1250 vehicle per hour per direction. So, 1250 into 1.63. Now, it will be not vehicle, but it will be now PCU per hour per direction. So, 2038 is the volume. Now, what is the operating speed? Adjusted operating speed is the base operating speed, and on that you have to apply correction with respect to IRI for grade and for curvature. So, that operating speed is given as 100, that sorting is under base condition operating speed, and then gradient is 1.4%. So, that is given, GR is taken as 1.4, IRI is 3.6 meter per kilometer. So, that you feed, and remember these are the corrections we are doing on operating speed, not directly on capacity, operating speed, right. So, once you have calculated the adjusted speed 77 per kilometer per hour, then you use the appropriate equation what has been given there 30 into V operating speed plus 1540. So, you get capacity is 3850 PCU per hour per direction. So, the volume also is known in PCU per hour per direction, capacity is also known. So, we can directly get the volume to capacity ratio, and since the speed is SMS is 40 kilometer per hour. So, speed is also known. So, speed is known, volume is known. So, the density also can be calculated. So, that is what, but before that the capacity is adjusted further to take care of this PSW, paved shoulder width and unpaved shoulder width. So, these are again adjusted. So, PSW is calculated and then accordingly C adjusted is 3662. So, this 3662 is actually the capacity which is to be compared with the traffic volume 2038. Okay. So, you can do that and you can directly get the volume to capacity ratio. Also 2038 is your actual volume and 40 kilometer per hour is the speed, specimen speed. So, you can also calculate the density which is 51. So, you also have the value of density, you also have the value of volume to capacity ratio. Now, you refer to table 3.8 of Indo HCM 2017, that is this equation which is for 4 lane. So, you know the density thresholds are given, V by C thresholds are also given, both you can check. So, you checked both here and both cases you found that it is indicating both in terms of density value and in terms of V by C, it is indicating LOS D. Now, the second example, determine the number of lanes required to maintain LOSB during peak hour for a new facility in a plain terrain. So, it is a new facility. So, many of the values will not be known except the ADT. The annual average daily traffic is known 20,000 vehicle per day. Design speed is assumed as 100 km per hour. Proportion of ADT during the peak hour is taken as 8%, normally 8 to 10%. Proportion of peak hourly volume travelling in the peak direction. So, that is taken as 0.6 and traffic compositions are also given. All these are input. So, what we can do? We can get the directional design hourly volume. What is that? ADT 20,000 into the proportion of ADT during the peak hour. So, 0.08 and in the peak direction multiplied by 0.6. So, that is what is done 20,000 into 0.08 into 0.6. So, get peak hour traffic volume, and again since this is not a new facility. So, you do not know really how much what will be required, but let us assume that operating speed as 100 km per hour and we require actually a 4 lane divided highway, and then we can test whether the 4 lane divided highway is adequate. Then the proportions are known, numbers are known. So, you calculate stream equivalency factor, which is come out to be 2.67. So, the design directional hourly volume 960 vehicle per hour multiplied it by 2.67. So, now you get the directional design hourly volume in PCU per hour 2563 PCU per hour. Now, you calculate the capacity, which is using this operating speed. Now, from table 3.8 you can get the maximum V by C threshold for this 4 lane divided road. If you want LOSB, the V by C threshold is 0.3. So, if the capacity is 4540 and then with that operating speed and the threshold is 0.3 V by C. So, then you know that what is the threshold service volume. So, service volume corresponding to LOSB is 1362. Now, if you know it is 1362, then how many number of lanes are required to serve this 2563 PCU per hour per direction? 2563 divided by 1362. So, you need 1.88. What we have assumed here? 4 lane divided. So, 2 lane in each direction. So, we are able to maintain that LOS once you provide 2 lane in each side. So, thus 2 lanes are required for each direction and 4 lane divided highway needs to be provided, and also our assumption is correct. So, this will be able to maintain, as we said, LOSB during the peak hour for a new facility in the peak terrain with all this for this all input data. So, with this what we discussed actually in this lecture, the capacity and LOS estimation for multi-lane divided highways. Again told you how you calculate stream equivalency factor, how you do the base capacity estimation, what all adjustments you do on operating speed and then thereby in the capacity, and what adjustment you do directly on capacity, then how you do the LOS estimation, and then took 2 small example problem to show you the applications. With this I close this lecture. Thank you so much.